50 amp subpanel typically does not have sufficient ampacity to safely install both a central air conditioner and a washer-dryer, each requiring 30 amps at 240 volts. The combined load of 60 amps exceeds the subpanel's rating. There is no derating factor that would allow installing both units on a 50 amp subpanel. The derating factor for copper conductors is 80%, which means only 80% of the rated capacity of the subpanel can be safely drawn. To safely install both units, you will need to upgrade the subpanel and install a dedicated circuit. To upgrade the subpanel, replace the 50 amp subpanel with a 70 amp or higher subpanel. To install a dedicated circuit, install a dedicated circuit for each unit, including the appropriate wiring, circuit breakers, and outlets. Additional considerations include wire size, circuit breakers, and grounding. Firstly, use copper conductors with a wire size that is appropriate for the load demand of each unit. Secondly, install circuit breakers that are sized properly for the equipment being supplied. Thirdly, ensure that all equipment is properly grounded. It is essential to prioritize safety when working with electrical systems. Always follow local building codes and consult with a licensed electrician if you have any doubts or concerns. Here is a more in-depth explanation of the important points. Let's start with calculating the load. The central air conditioner requires 30 amps at 240 volts and the washer-dryer requires 30 amps at 240 volts. The total load is 60 amps. Next, let's examine the subpanel capacity, which is rated at 50 amps. Given that the total load exceeds the subpanel capacity, an upgrade is necessary. The National Electrical Code, or NEC, provides guidelines for conductor ampacity and overcurrent protection. Table 310.15b16 details the ampacity of insulated conductors rated up to 2000 volts 60 degrees Celsius through 90 degrees Celsius in free air, based on the conductor size and temperature rating. It's essential to select conductors with an ampacity suitable for the calculated load, considering any applicable derating factors. For example, if the conductors are installed in a conduit with multiple current-carrying conductors, a derating factor may need to be applied to reduce the allowable ampacity. Overcurrent protection devices, such as circuit breakers or fuses, are designed to protect conductors and equipment from overloads and short circuits. The overcurrent protection device should be sized to protect the conductors based on their ampacity as specified in NEC section 240.4. It's crucial to choose the correct type and size of overcurrent protection device to ensure proper protection and prevent nuisance tripping. Regarding the derating factor for copper conductors, NEC section 310.15b3 specifies that when conductors are installed in a raceway or cable with more than 3 current-carrying conductors, the allowable ampacity of each conductor must be reduced. The derating factor depends on the number of current-carrying conductors and the ambient temperature. In general, the derating factor for copper conductors is 80%. This means that you can only safely draw 80% of the rated capacity of the subpanel. Therefore, with a 50 amp subpanel, you can only safely draw 40 amps. To address the situation, upgrading the subpanel involves replacing the existing 50 amp subpanel with a subpanel that has a higher ampacity rating. A 70 amp or higher subpanel would provide sufficient capacity to handle the combined load of the central air conditioner and the washer-dryer. When upgrading the subpanel, it's essential to ensure that the existing feeder conductors and overcurrent protection device are also upgraded to match the new subpanel's ampacity rating. This ensures that the entire electrical system is properly protected and can safely handle the increased load. Alternatively, installing a dedicated circuit involves running a separate circuit for each unit, including the appropriate wiring, circuit breakers, and outlets. This approach isolates the loads and prevents overloading the existing subpanel. Each dedicated circuit should be sized to handle the load demand of the specific unit it serves. For example, a 30 amp 240 volt dedicated circuit would be suitable for both the central air conditioner and the washer-dryer. When installing dedicated circuits, it's essential to follow NEC guidelines for conductor ampacity, overcurrent protection, and grounding. This ensures that the circuits are installed safely and comply with all applicable codes and regulations. Let's further examine wire size. The selection of the appropriate wire size is crucial for ensuring the safe and efficient operation of electrical circuits. NEC Table 310.15b16 provides guidelines for conductor ampacity based on wire size, insulation type, and temperature rating. It's essential to select conductors with an ampacity that is sufficient for the low demand of the circuit, considering any applicable dating factors. For example, a 10 American wire gauge or copper conductor with a 75 degrees Celsius insulation rating has an ampacity of 30 amps. This would be suitable for a 30 amp circuit, provided that there are no other factors that would require dating the conductor's ampacity. Next, the proper sizing of circuit breakers is essential for protecting electrical circuits and equipment from overloads and short circuits. NEC Section 240.4 provides guidelines for overcurrent protection, specifying that the overcurrent protection device should be sized to protect the conductors based on their ampacity. In general, the circuit breaker should have a rating that is no greater than the ampacity of the conductors it protects. For example, a 30 amp circuit should be protected by a 30 amp circuit breaker. Finally, proper grounding is essential for ensuring the safety of electrical systems and preventing electrical shock hazard. NEC Article 250 provides guidelines for grounding and bonding, specifying that all electrical equipment and enclosures must be properly grounded. Grounding provides a low impedance path for fault current to flow back to the source, causing the overcurrent protection device to trip and de-energize the circuit. This helps to prevent electrical shock hazards and minimize the risk of fire. The importance of prioritizing safety cannot be overstated when working with electrical systems. Electricity can be dangerous, and it's essential to take all necessary precautions to protect yourself and others from harm. Always follow local building codes and consult with a licensed electrician if you have any doubts or concerns. Building codes and regulations vary depending on the location, and it's essential to comply with all applicable requirements. Local building codes often incorporate the NEC and may have additional requirements that are specific to the area. Consulting with a licensed electrician is always a good idea, especially if you are not familiar with electrical work. A licensed electrician has the knowledge, skills, and experience to safely and effectively install and maintain electrical systems. They can also help you to ensure that your electrical work complies with all applicable codes and regulations. In summary, before deciding on a final solution, you should perform a load calculation based on NEC Article 220. This calculation will determine the actual load that the apartment will demand. This is the only way to accurately assess the size requirements of the new sub-panel.